Hello, Amal sir.
Yes, sir. Yes, sir. You are audible now.
I'm audible, no?
Yeah,
Yes, sir. Yes. Hello, Namaskar, Nerkar sir.
हाँ नमस्कार सर. स्क्रीन शेयर हो रहा है क्या सर?
हाँ,
स्क्रीन शेयर हो रहा है क्या? मेरा अभी पीपीटी
स्क्रीन शेअर करा सर तुम्ही.
खाली खाली ऑप्शन असेल शेअर स्क्रीन म्हणून बॉटमला.
स्क्रीन शेअर आलाय का तुम्हाला? नाही ना? पीपीटी दिसतंय का?
No, sir.
नाही.
No, sir.
ओके. विजय बोला ना विजय शेयर का बटन क्लिक हो रहा है. ये अपने बंद किया इसलिए है. सब जाना है. हाँ विजय हे बघ ना शेअर होत नाही आहे. जरा बघ ना. अच्छा अभी आहे. आता पीपीटी ओपन करू का? मिनिमाइज करतो.
Yes, sir. Now it's visible. The screen is
ओके
visible.
ओके सर एक मिनिट. Okay, now visible?
Yes, sir.
Okay. हाँ झालं सर. ओके.
हॅलो हॅलो नेरकर सर. हॅलो हॅलो.
हा हॅलो.
हा सर
नाव
नमस्कार.
ऐकलं? नमस्कार सर.
सर मी काय म्हणतो सर, एक
हम्म.
रिक्वेस्ट होती की एचओडी बोलतो राजेश काळे.
हा बोला सर. नमस्कार.
एक रिक्वेस्ट होती की आमचं 4:15 पर्यंत कॉलेज असते.
ओके.
हा तर एक 4 वाजेपर्यंत समजा तुमचं लेक्चर संपलं तर
हम्म.
5-1 मिनिटात क्वेश्चन आन्सर 5-10 मिनिटात क्वेश्चन आन्सर सेशन होऊन आम्ही 4:15 ला निघू शकतो. म्हणजे स्टाफ बाकीचा लांब लांब राहतो बराच.
हो हो. नाही नाही काय हरकत नाही.
चालेल
विल
ना.
ट्राय टू फिनिश अर्ली.
4 वाजेपर्यंत प्लीज संपवा मग.
हो हो.
आहे ना. ठीक आहे.
चालेल चालेल
कारण
चालेल.
लंच टाइम अकोमोडेट करायला आम्ही असे टायमिंग ठेवले.
ओके.
अदरवाईज आमचं म्हणजे कसं होतं 1 ते 3 होतं आमचं दुपारचं सेशन.
हाँ 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 राइट राइट.
येस सर.
इसमें कोई पासवर्ड है क्या सर? मेरा एक कलीग जो साथ में है उनको ज्वाइन करना है. इज देयर इज पासवर्ड और लिंक? हेलो काळे सर.
नाव काय सांगा.
हेलो.
येस टेल अस यार नेम सर. तुम्हाला जी झूम लिंक पाठवली आहे ना दॅट यू कॅन युजिंग दॅट लिंक.
आवाज
त्यांचं नाव जर सांगितलं तर मी विल अलाउ यू टू
म्यूट किया.
आपण झूम वर जॉईन करू.
इसमें
आवाज खूप कमी होतो सर तुमचा. खूप कमी आहे आवाज तुमचा.
मंगरुळकर सर त्यांना सांगा
हा.
त्यांच्या कलिगला जॉईन करायचं आहे.
अच्छा.
हाँ
तर त्यांना ती झूम लिंक द्या आणि त्यांचं नाव आपल्याला सांगितलं तर आपण ऍडमिट करू त्यांना.
हा
हाँ वो
झूम
आप
लिंक दिलेली आहे सरांच्या याच्यावरती मी पाठवली आहे. मेल आणि व्हॉट्सअप दोन्ही केलेलं आहे.
हो त्यांचं नाव जावेद पटेल त्यांचं नाव आहे.
जावेद
अच्छा
पटेल.
अच्छा.
अच्छा ठीक आहे
हा.
ठीक आहे. सर झूम लिंक द्या तुम्ही, आम्ही जॉईन करून घेतो.
हो दिली झूम लिंक दिली त्यांना.
सर पानसकर सर.
Yes, sir.
जावेद पटेल म्हणून आहे, त्यांना ऍडमिट करायला.
Yes, sir. Yes, sir. Okay. Good afternoon, all. I, Professor N.J. Panaskar, on behalf of Institute Rajiv Gandhi Institute of Technology. Sir, good afternoon, all. I, Professor N.J. Panaskar, on behalf of MCT's Rajiv Gandhi Institute of Technology and Department of Mechanical Engineering, welcome you all to the AICT AQIS sponsored online short-term training program on recent trends in energy management and audit. Our speaker of today's session is Mr. K.R. Nerkar from Adani Power. He is working as additional VP Electrical Maintenance His industrial experience includes erection, commissioning, operation and maintenance in thermal power plants and energy auditing and energy conservation activities in thermal power plants since 1992. He has been involved in erection, commissioning, operations, energy efficiency, and overhauling activities of 250 megawatt, 300 megawatt, and 660 megawatt steam turbines, solar plants, and its auxiliaries. Erection and commissioning of 25 megawatt biogas power plant. He has done his BE in electrical power systems and also MBA in finance. Additionally, he has also a diploma in industrial safety. He is an energy auditor with 6 Sigma Black Belt certification. He has also presented papers at CCI, MEDA, FCCI on energy conservation and switchgear reliability topics. With this, I would like to hand over to Mr. K.R. Nerkar, sir.
Thank you, Panaskar, sir.
Welcome, sir.
The slides are visible now.
Yes, sir. Visible.
Good afternoon, friends, and good afternoon, sir. So this is a very good initiative for sharing the experience from the practical experience or industry experience with the education field or your faculties, all faculties, because we also know how the recent trends in the industry now. And this is a very good initiative, and we are trying to contribute in that. So today's morning, already Mr. Suhas Patil has taken the audit energy management system, but out of that, I am taking that motor audits. I am audible, sir? No?
Yes, sir.
Hello.
You are audible.
Okay.
Audible, sir.
So now we'll start the motor audits. Motor audits is a very important topic for any energy auditing system. We'll see that is my presentation is in the aspects of need of energy conservation, energy management, electric motor efficiency, energy audit of motors, and energy management system, and forward paths. What are the forward paths? We can learn from that. And this is just some topic, maybe that is just revision for you, because you know better theory than me also. But I will try to explain the many things which we are having the experience about that. So first we'll see that is the energy conservation, need of energy conservation, because any country is economy depends on the energy consumption. Then that energy consumption is decide what is the economy of that country. So for developing countries, basically the energy demands are increasing, and that to cope up that energy demand, we require the more investment, because for putting the any power plant nowadays, suppose in thermal power plant, 6 crore per megawatt is a cost, or even in your solar power plant around 10 to 12 crores per megawatt. So these are the cost, heavy cost is involved for this providing the energy. So on that basis, here is the energy can be classified into several types based on the following criteria. You can say that is primary and secondary energy, commercial, non-commercial, and renewable, non-renewable, as you know already. Then you can see every day we know about what are the different types of energy in your life. That is the electricity basically. Then biomass energy, geothermal energy, fossil fuel or coal, oil, natural gas energy. That is a primary fuel, you can say. Hydropower, ocean energy, nuclear energy, you know, solar energy nowadays, it is a very important topic for the solar energy. Then wind energy. The last two are solar and wind energy, renewable energy sources that we are focusing more in nowadays. But these are the main energy sources or energy we are coming into contact day-to-day life. But now this is mainly this 85% of the energy is from the primary energy. We are generating till date, we are generating the energy, whatever energy requirement of the India, that is our electricity energy, you can say it is generated from the primary fuels, and that primary fuels are continuously diminishing with increase in the consumption, and will exist the figure. Sometimes comes that there is no primary fuel is available. In that time, you are 100% dependent on the renewable energy. So for that purpose, we should think about the conservation of energy. Not but that is the main purpose of this energy auditing of the all the systems. Then another point is that need of energy conservation. Why energy conservation is very important? Because there is some simple point is that is a process, that is, you can say, primary fuel. This is a standard process you may be knowing about completely, but power plant as substations, transmission line substations, and domestic and commercial industries. This flow diagram, you can say that each point having that there is a efficiency or loss of energy. That means here you can see there is a generation, there is a 28% efficiency of turbine, or you can say complete system, Rankine cycle system, as you know, the mechanical system. So in generation, the Rankine cycle efficiency around 28 to 35%. Maximum side nowadays is 39%, 39 to 40%. But other than that, there is our step up transformers, there is a 99.5 efficiency, there is a loss. Transmission line, there is a loss. Then a substation, there is a loss. Distribution system, there is a loss. So that way, this you can see that is whatever we are 1 unit, we are getting 1 unit, but for getting that 1 unit, we require to generate the minimum 2 units. That means when we generated 2 units, then only we can use the 1 unit because of the losses in the line between the system or process. You can say process losses or transmission losses. That means you can remember that you can see that 1 unit save. If you can save only 1 unit, small 1 unit, you can say that means you are generating the 2 units. Directly we are generating the 2 units, and 1 unit save means we are saving the coal of 0.561 kg and 0.95 kg CO2 for 1 unit. 1 unit if save करेंगे तो 2 unit generate होगा. तो इस केस में you can save around 0.5 or 0.95 kg CO2. That means pollution also you can help in the environment system also. So that's why conservation concept is very important, and in every person it should be inculcated. Then next we will see that there is energy conservation. We see many times that energy conservation and energy efficiency. What is? I am audible, sir? No? Hello.
Yes, sir.
If anything, you can immediately point out, sir. Then there is a two concept, that is energy conservation and energy efficiency. There is a many confusion in that. What is the energy conservation? What is the energy efficiency? Energy conservation means simply without changing the technology, without changing any equipment, without changing the, you can say, only by controlling the operations, or you can plug, you can say, unproductive equipment or energy, unproduction energy, plugging that in, that is called the energy conservation. As an example, we have seen that is just there is a one lamp, you can say, but we incorporate, there is a control system for lamp, that is remote sensor, dusk down timer system, or you can say occupation sensor. That is when it requires, that time only it become on, otherwise it will off. That is nothing but, you can say, energy conservation. But energy efficiency means that is the equipment efficiency or light efficiency. That means here also you can see that is a suppose lamp. That's incandescent lamp is a simple example that I am taking. The lamp we replace with LED. That means we are increasing the efficiency of that light, or that is illumination will increase. We require less power. That is nothing but the energy efficiency. So these are the two parts, but we should work on both of them, conservation also and efficiency of the equipment also. Then we can see the why we are focusing on so much. Because if we do the conservations and energy efficiency in our plant or in our house also, in day-to-day life, what will affect? So first you can say in industries, we are major in the industry, you can say reduce energy bill. There is a, what is the energy conservation.
Hello, Nerkar sir. Hello. Nerkar sir, am I audible to you? We are not able to listen you for the last 2-3 minutes. हाँ हाँ आज टू अनम्यूट केले मी त्यांना.
Hello. Now I am audible? Yes,
Yes
sir.
sir, now you're audible.
It is muted. Why it is muted? I don't know
Yes,
about.
last 2 minutes it was muted.
But okay, from our side, I am not doing anything for that. Okay. Still, we'll see. Then last. You see the point? Right. किसी का प्रॉब्लम हुआ है हेलो
Hello.
the device sound is coming, I think. I think बाकी others का mute कीजिए. So if any questions is there, we can give the time for the question also. Sir, can I start? Yes, sir. Hello.
Sir, yeah, sir, please start, sir. Sorry for
No problem. No issue. Then this is I already explained. Then energy management means the concept of energy conservation, energy efficiency at all level of energy consumption. Energy management basically you can see the maximize the enhance the competitive of the position of the industries or product, we can say. Elements of energy management process is identification and analysis of the energy loss. Then this is a energy usage process, fuel substitution, energy distribution. We are thinking
Sir,
now.
sorry to sir, your screen is not visible. Screen is not visible. PPT.
1 minute. Okay, now is visible.
Yes, sir. Now it's visible, sir.
Okay.
Put on presentation mode, sir.
Okay, no. Okay, sorry for disturbance. Then why the energy management? Why only in motors? Motor is a very why people are asking what is the question for why motor is required only for? Because in any industry you can see the motor is a main energy consumer. Anything you can say the all the any industry you can consume or in a house also you can see the motor is the main consumer. Then that you can say the total out of 85% of consumption our consumption by the motor. Because motor we are getting the losses or efficiency of motor, or you can say there is a in industry all drive system is driven by motors. So 80% consumption you can say the motors. That's why you are considering the motor is a or audit point of view or any process audit, motor is the main part of that system. Another point is that motor is a equipment that is a running cost of that equipment is more than 100% of your operating your capital cost. That means operation cost is very high in your motors, any motors. As an example I shown you, that is if you have car, the car there is supposed to maintenance to 2,50,000, your operating cost per month 2,000, around is 1%. or personal computer around is 1%. Similarly, washing machine around 200 operating cost, it's 1%. But if motor is there, motor operating cost is very high, is more than 100% or 100%. And its cost is 20,000, but in running life years, its cost of the motor is very high. Operating cost is very high. That's why motor, we have to take the motor for the energy auditing purpose. So on that form, we are considering the motor for the main consumption of the power. Then benefit of energy management for electrical motor is saving of energy, reduce the operating cost, minimize downtime, increase productivity, improve the environment also. Similarly, just we explain this one. Then once we are identified motor is a major part for the auditing, then we should know the what is the motor, what types of motors are available, what is the losses in the motor, what is the efficiency of the motor, that we should know. So for that point of view, I am representing these some 5 to 6 slides for the motors. That is, as you know about that, AC or DC motors, there are different types of motors on the basis of supply: synchronous motor, induction motor, squirrel cage motor, or slip ring motor on the basis of rotor. Then in motor driven system, I already trying to explain you that is how motor is run. Motor, you can say here you can say power supply. You are getting the power supply from the power source or power plant or any system, substations. That electricity we are getting from this electricity, it is connected to the your starter, sensor, metering, variable frequency drive, or any control system. That control system is input for the motor. Motor output is connected to the through power transmission through belt, direct connection, clutch, gears, coupling, and that is again connected to mechanical system, pump, fan, compressor, any system. And the output of this system mechanism, we are getting the process, that is flow, mixing, grinding, handling, whatever. This is the cycle of the motor, you can say. Process, motor process, how motor is run, how motor is consume the energy. For any process, we require to run this motor. So that is the main part of this consumption of motor, you can say. Next, we'll see this application, that is already explained. Pumps, fans, everybody knows about what are the many motors. Many applications are there. In small, even printer also there is some stepper motors. Different in each and every take there is an application of motor is there. But here is a motor that is simple. I am taking all motor characteristic. That is the speed. Motor speed. Motor speed, as you know, the synchronous speed is equal to 120 F upon P. F is the frequency and P is the number of poles. From this formula, you know that you can change the speed of the motor by changing the pole, or changing the frequency. These are the main characteristics of your any induction motor I am talking about, or any motor you can see. Then power factor. Motor power factor क्या होता है? Motor power factor, as you know, everybody many times linkage, because nowadays in energy meters there is a point as a power factor. MER sharing is high. MER sharing, then there is a penalty for the each consumers. That's why everyone is trying to maintain the power factor. That's why what is the power factor? Cos phi is a kilowatt upon kVA, or you can say cos phi of your phi is nothing but the angle between the voltage and current. So this is a power factor also plays a very vital role in the motors. As a load on the motor reduce, active current reduce, but there is no corresponding reduction in magnetizing current, hence power factor reduces. So power factor reduction is the induction motor is very, very high, or it is normally in lagging power factor is normally in all the induction motors are lagging power factors are there. So for that purpose, lagging load purpose, power factor correction is required. You can put the capacitor and you can correct the power factor of that. Similarly, motor operating below their rated capacity are the main reason for the low power factor in electrical system, because some of the motors are high capacity, but they are operating a low load. So that time also their power factor is very less. You can see the graph, that is the efficiency of motors and power factor of motors. Here you can see as a maximum around 70-75% of loading, there is a corrective power factors we are getting, or efficiency, maximum efficiency we are getting in that. But here you can see the power factor trends and the efficiency trend of motors. And now you are normally operating 80-85% of the percentage load. And in that case, you are getting the maximum power factor of that motor, you can say. So that's why power factor calculation is very important for the auditing point of view or for the motor loading point of view. Then here you can see, as everybody knows, the efficiency is nothing but your output upon input, or it is output upon output plus losses. Simple formulas, but here you can see, I am audible, sir? Hello?
Yes, sir, you are audible.
Okay. Then therefore, for increasing the efficiency, we should reduce the losses. That is also know everyone. But what are the losses in our motors? Because we are carrying out the audit of motors, so you should know about the motor. What are the chances of losses, or where is the losses in the motor? So in that you can say figure. I am trying to explain or indicate only that is a stator ISK loss. Where is that is the winding stator ISK loss? Core losses, where is core losses here you can say, and here is a friction and windage losses, bearing, or you can say shaft bearing area, you can say fan area. Then stray losses, leakage flux is there, stray losses are there. Then rotor IR losses are. These are the losses, and these losses you can say here is one tabular form. We come to know that if there is a speed is low, the losses are high. So normally there is a many times if possible you can increase the speed of motor, and you can put the low speed instead of low speed, you can put the high speed motor, so that the losses are reduces and we can increase the efficiency of that motor. Then we'll see the here you can see that is a losses pie chart. You can say that is a stator 34%, rotor 21%, mechanical losses 10%, and iron losses 14%. Definitely there is some losses definitely will be there, but we can try to minimize the losses by adopting the new technology, adopting the new efficiency motor. Then you can see here by sometime people are say what 1% से क्या हो जाता है, कुछ फर्क नहीं पड़ता. अरे फर्क पड़ता है, क्यों पड़ता है? You can see here one simple example for a 373 kilowatt motor, 500 HP motor with 94 efficiency है at 80% loading. The required input requires 317.45 kilowatt. If same motor we can with 95% efficiency हम करते हैं same loading के ऊपर, your consumption is 314.11. That means you can save 3.34 kilowatt. You can see that 3.34 kilowatt, though it is looking very small for one motor, but it can continuous basis on yearly basis. You can see how much saving will be there. You can calculate 3.34 into 24 into 300 years, 300 months, 300 days for the year, you can say, other than shutdown. So you can calculate how much will be the power saving possible through the only by changing the 1% efficiency of the motor. So that's why there is though there is a small changes, small efficiency gain, you try to adopt that one. Next, similarly then question arises, भाई ठीक है मोटर में आप बोल रहे लॉसेस है, तो उससे क्या कर सकते हैं हम लोग, उससे कैसे कम कर पाएंगे? How we can reduce the losses? But then there is a suppose stator है, rotor है, there is a standard practice you can say, or now new standards are coming nowadays. Suitable selection of copper conductor for the maximum material for the stator winding, copper cage rotor, especially is an aluminum die cast rotor. Then low at loss material को core loss का जो है आपका thinner lamination होना चाहिए, ensuring reduce bar height होना चाहिए, mechanical losses में bearing selection properly होना चाहिए, optimal design fan का optimal design होना चाहिए. Normally इसमें क्या होता है, fan एक बार मोटर आ गया, मोटर के साथ OEM ने फैन भेज दिया है, फैन एक बार आपका खराब हो गया तो रिप्लेसमेंट में कोई भी फैन लगा देते, then it will reduce the efficiency of your motor, because it optimal design or design as per design which type of fan is required, that fan should be installed for the at the time after repairing for us or maintenance point of view. Another stray load losses, optimal slot geometry or design of the slot of the motor, we can reduce the losses in the system. Then falling factor also affected. These are other than these, the design factor, other factors also affect
Hello, sir. Hello. Hello. Nerkar, sir. Hello. Nerkar, sir. Your screen and your voice is not audible. Yeah, I think so. Because of network issue, sir has lost connectivity. Sir will resume again. Nerkar, sir.
सर फोन
Yeah, dear participants, due to some network issue, our expert has left the meeting. He will rejoin in 5 minutes. Kindly consider. Hello. Nerkar, sir. Am I audible?
गया गया हुआ चालू? हाँ हो गया, चालू हो गया। तो फोन पे तो आ गया, देख के ये लगाओ क्या?
Hello. Sir,
हाँ हेलो
welcome
सर,
back, sir.
चालू हो गया।
हेलो,
Hello. Yes, I can hear. Hello. Nerkar, sir.
कुछ ज्यादा वीडियो पे ज्यादा लगता है ना?
Yes, sir. Now you're audible, sir.
ऑडिबल?
Yes, yes, sir. But your screen is not visible.
हाँ, now.
Yeah.
Okay. Now it's visible?
Yes, sir.
Yes,
Your
sir.
screen is visible. Yes, sir.
Okay, sorry for interruption. This is a net problem, I think. So there is a problem actually. Okay, we will start.
Yes, sir. Please continue, sir.
Please turn on sir presentation mode, sir.
Okay. Now that the factors affecting motor performance of motor, you can see that the voltage variations. You can see here the reduce the input voltage, the motor output will reduce and losses will increase. The copper losses will increase by a square of delta V. That means the voltage variation is matters. The torque is, you know, that is the torque is proportional to the square of voltage and is proportional to slip. When the voltage decreases, the torque decreases, and the maintaining the torque, the slip increases and speed falls. You can see here that at 10% voltage drop, the torque reduced by 19% and current increased by 11% of full load current and efficiency reduced by 1.1%. That means though you can see what is the effect of voltage variation on the efficiency of motor. नेक्स्ट विल सी द हार्मोनिक. हार्मोनिक से भी क्या होता है? हार्मोनिक से भी सेम है, इसमें एडी करंट लॉस बढ़ता है बिकॉज आयरन लॉसेस बढ़ेगा, इसकी वजह से करंट बढ़ेगा, हार्मोनिक करंट की वजह से वाइंडिंग लॉस बढ़ेगा और हार्मोनिक से आपका एफिशिएंसी डाउन हो जाएगा उसके. सो फॉर दैट पर्पज वी रिक्वायर द स्टेबलाइज वोल्टेज एंड यू कैन से सम स्टेबलाइजर और फिल्टर्स रिक्वायर्ड फॉर दैट वोल्टेज इनपुट. Then loading factors, that we already know about that. What is the loading? Loading is very important in the motor system because it's a no load. That means there is a low power factor and low efficiency of the motor. So you can find out where is the loading factor. What is the loading factor of the or in industry, or you can see in any other areas. Then rewinding. Rewinding is also one of the factors. That is many times we are doing. We are doing the rewinding of motor from the local vendors or non-standard vendors. What they are doing, they are heating up the all the for removing the winding. They are by using, we can say, crude method. They are heating the all core, and that due to the heating, there is a insulation damage and eddy current loss will increase, and that is also increase or decrease of your efficiency of the motor, rewinder motor. So rewinding of motor, you should be ensure that it is properly rewinded, proper material are used or standard methods are used for that. And after that, it will reduce the efficiency more than 1 to 2%. That one. Then next you can see these are efficiency standards. Before that, we will show that these are the standards, normally efficiency standards nowadays. That is the IE1, IE2, IE3, IE4. That is the standard efficiency IE1, high efficiency IE2, premium efficiency nowadays people are looking for that, and super premium efficiency IE4 is in now in R&D, or you can say some places we are using for that. These are the common efficiency for the all. You can say US there is different standards, European there is different standards, China having the different types of measure. But there is nothing but efficiency standards of motors or for that part. You can see for India. In India, you can see I am showing here this IS 12615 past and present. Now, initially to 2004, what is the condition? Now there is a 2015, 11, there is a change. Now 2014, there is a change. In this change, that is everyone, there is a I3 is compulsory from the 2014 available in market. Now I1 is a not I1 motor should not be manufactured. But you can say, you can ask anybody when you are purchasing the motor, which standard you are using, that we can ask for that. Or you can say simply you can see here what is the efficiency change, technology change in the motor system. Here the IS325 is a ban, now it is not no more there. Then this IS 12615 2011, you can see here also I1 is not used, and now in 2015 now I3 is people are going for the I3 I4 process. These are the trend for the efficiency, motor efficiency on the point of your manufacturing system. You can say material, quality of material, metallurgy of the equipment, and metallurgy of the conductors, or you can say cooling system, or you can say design of the motor. These are the standards now increasing. These standards, you can see from the standard motors to efficiency motor, there is a variation of the efficiency to 15% efficiency, and you already know the 1% change in efficiency, how much you can save. So there is a very change in the efficiency of the motors in there. So for that, one example I am showing, there is one motor is 11 kilowatt, both are 11 kilowatt motor, and here you can say there is a loading also, percentage loading 100%, efficiency 89.2% and 92.5%. This is efficiency 2, efficiency 1 motor. That is China, you can say efficiency 2, efficiency 1 motor. European system, that efficiency 2 is a layer and efficiency 1 is a higher efficiency motor. Then kilowatt rating, you can say here 100%, utilization rate 24. Then energy consumption, you can see here, or power tariff 5.5 kilowatt, or you can say the purchase price. Now the question is that now because high efficiency motor are in market, but cost is high. Cost is little more high, 20-30% cost is high. So that's why people are hesitating to purchase that motor, because everyone think about the budget. कि इतना पैसा कम खर्चा होगा तो अच्छा है. But yeah, they are not thinking about the long term. You can see here that's why I am giving the example. This cost is higher, 21,499, and here is a 15,818. So you can see the cost is small higher, but payback period of this cost, you can these are that approximately 3.4 months. Within 3 months, this cost is recovered, extra cost is recovered, and within 1 year, the total cost of the motor will be recovered, and we will get a higher efficiency, and we are giving the savings the energy of it. That's why high efficiency motor normally you should prefer, not only in industries, also in your house, also in our normally people are purchasing AC. But that you should purchase 5-star AC only, because the operating cost of AC is very high. That's why after long term it will be saving to the energy also and your human also. Then you can see here these are some opportunities for the motor conservation of energy in motors. Efficiency, just one of we seen VFD installed in some places. Check up bearing cooling system, set up filter stabilizer for voltage purpose. Failure rewinding of motor, you can say. Check up under voltage conditions of the equipment. High speed motor whenever possible. Use a soft starter for the if possible to the system. Then point is that next is the audit. What is audit? Till that we see what is the energy efficiency, what is the energy scope, or what is the improvement scope in the motor, how we can improve the motor. But now first we should know the how the performance of motor in our industry. So that's why audit is important. So audit, there is a basic background for audit is considering identify the potential energy saving and use of energy efficiency in various sector industries. Government of India enacted the law. That is a law, Government Act, Conservation Act 2001, and it is implemented from the 2002, January 2002, it is implemented. And through this act, there is a audits are compulsory. We have to all designated consumers or high commercial consumers, they should carry out the energy audit of their system. Or you can say building also. Now with all buildings also, commercial buildings also, there is a law in that they should carry out the audit. And in that audit, they will identify the where is the losses in their system. And the main objective of this audit is to minimize energy cost, waste without affecting the production quality, and minimize the environment effect. That's why energy audit is compulsory. The flow diagram of energy audit process, you can say, is that first you know the audit people, there's a team, we should know the necessity of system and the objective of audit. That means system also we should know. But once we should know with this motor is used or this pump is used for what purpose and what is the significance of that motor or pump. So then once you know the system, then only you can carry out the audit systematically or preferably in the line of requirement. Objective of auditing. Then next is data collection. Comprehensive data collection is required for that. Then observations, then analysis the data, find out the observations, then exploration of energy conservation project on the basis of data analysis, and then report preparation. This is a standard simple procedure for this. But this procedure, why sometimes people are, this is a common procedure, why people are giving this one. But still, governments are insisted that these are some standard procedures required. Otherwise, it should not be man-based. One company doing other way, other company doing other ways. So that by purpose, there is uniformity purpose. They are doing the standard procedure. See, also given standard procedure, what type of procedure, which type of formats are used for this auditing purpose. These formats are applicable to all industries. Similarly, just a nameplate data even. Data collection part in auditing is very, very important. Because data will show you what is the actually position of your in the system, what is the efficiency, what is potential of energy in the system. So data collection is a very important part. You should know what to be collect, when to be collect, and where to be collect. That is the very important point for the measurement of the data. Data collection is a very important point in any auditing system. So here I just given that is also standardized by the government. That is the ID code application, all these things. Then measurement observations. So even once the data is collected, what parameters should be just I tell about what parameters should be paid, when to be paid, how much data to be collected. That should be finalized. Just electrical parameter, you can say kilowatt, kVA, PF, power factor, ampere, voltage, hertz, and harmonics. Then daily lena, monthly, yearly, like that data, individual motor data to be collected. Unit, that time, what is the unit? That means suppose our unit is suppose 250 megawatt unit. Now unit is running for 1 is a no use. Otherwise you should mention that the unit load is this much. Different load you can conduct. Otherwise, just now is a 150 megawatt, sometime is 100 megawatt, say 250 megawatt data is more relevant. That time you are all running at more relevant data. On that basis, you can take some decisions. So at what load, system load, or you can say production load, on basis you finalize the data collection point. Then these are the formats given in this. That is as a more boiler feed pump you are given, condenser extraction pump, annual consumption निकालना आप लोग कितना हो रहा है और the particular equipment, load कितना है. Then टोटल जनरेशन, मतलब जैसा आपका टोटल पावर कंजम्पशन टोटल सब है, उसमें से कितना परसेंटेज आपका ये मोटर कंट्रीब्यूट कर रहा है. सो ऑन दैट बेसिस यू कैन फाइंड आउट दैट इज वन ऑफ द 2 or 4 motors are more counting. We can direct that, we can focus on that, and you can save the energy, more energy in that particular motors. So that way you can improve the efficiency saving in the system. Similarly, the observation here, this format I am particularly showing because ID fan motor. So we should take the data. These are the same motor ID with rated kilowatt, efficiency, flow measurement, harmonic, motor speed. These are everything is given. But here, similar motor data should be collected in one format. So here one ID fan 2, ID fan 3, ID fan 4. So from this format only we come to know the which ID fan is taking the more current, which ID fan is the more power, which ID fan have the scope. So you can collect that in such format, such other format. So easy analysis is very easy for that auditing purpose. From this auditing, mainly in auditing or data collection analysis, what is the purpose of audit? Audit is we should find out the potential. Where is the energy saving potential? For potential, instead of potential, we should find out where is the loss. कहाँ पे लॉस है, वो कहाँ हम उसको अपन रिपेयर कर पाएंगे. So इसलिए defect identification is very important. From the data analysis in the audit we find out where is the loss. Just like there is a loss in the system process में कहाँ लॉस हो रहा है, where is the potential for motor replacement, मतलब कौन सा मोटर का लोडिंग कम है वहाँ रिप्लेस कर सकते हैं, लोडिंग ऑफ मोटर कितना है, कौन से लोकेशन में, that is criteria you can find out that this is the loss. कंट्रोल फिलोसफी, कुछ जगह कंट्रोल फिलोसफी ऐसे है कि 24 आवर्स मोटर चल रहा है, जरूरत नहीं तो भी चल रहा है, तो इट इज लॉस. सो दैट व्हाट इज द कंट्रोल फिलोसफी ऑफ द सिस्टम. देन प्रोटेक्शन इंटरलॉक सिस्टम, सम इंटरलॉक इज गिवन, दैट इज वन मोटर चलेगा तो दूसरा भी चलते रहेगा, जरूरत नहीं फिर भी चलते रहेगा. तो इन दैट केस मतलब इंटरलॉक सिस्टम आल्सो to be redesigned, or you can say sometime it are waiting, unnecessary systems are running, so no load runnings, that also get in the loss of the system, energy loss of the system. So that way we can change the system. Then process requirement. Here one point is just what is the process requirement is also important. We should identify what is the process requirement. Suppose process requirement, suppose flow requirement, suppose any equipment system, there is a flow requirement 250 ton per hour, and our equipment is giving the 330 ton per hour. Then there is scope of improvement. Then you can reduce the speed, or you can reduce that way you can identify what is the process requirement, because we are not changing the process, we are using the same process. So process, for meeting the process criteria, what are the chances or what are the loss in the system, that we should identify in that. Then sometimes there is a design efficiency. Sometimes find some design efficiency in that, same process efficiency in that you can identify in that through the audit. Then safety factor, because some people are, initially there is a last 10-15 years back there is a safety factor. The motor requirement is 10 kilowatt, where we are purchasing the motor for 15 kilowatt. But रहना तो अच्छा है, बड़ा रहेगा तो problem नहीं. So that safety factor also, but there is a loss in the system because it never runs on full load. So you are not getting the higher efficiency, you are not getting the power factor. So there is a loss of the system. That way, the loss we have to identify by auditing. That's the main purpose. Where is the loss in the system? I am audible? Hello? Motoring not available. Technology.
Hello, sir.
Yes, sir. Yes, sir. You are audible, sir.
Okay. Design of over safety factor I explained. The monitoring not available. Some places there is a चल रहा है, मोटर चल रहा है, किसको मालूम नहीं कितना लोड ले रहा है, कितना करंट ले रहा है, कोई मॉनिटर नहीं कर रहा है. So that monitoring should also identify through this audit. There is no monitoring for the particular area. There is a consumption is there, but no one monitoring. So that type of losses we should identify the process system. Then technology operation. There is a very old motors or old systems, old pumps are using. Now new higher efficiency pumps are available. So that way we can find out the potential for the improvement. Similarly, maintenance practices. Some maintenance practices is not proper, not doing the overhauling of the systems, properly overhauling or maintenance of the system, bearing, lubrication is not given. That will also contribute the losses in the motor, or you can say losses in the system. That way you can find out the loss in the system. Once you find out the losses, then definitely we can find out the possibilities of the overcome of the losses. So that possibility by this method, like in replacement, sizing of motors, optimal for energy efficient motor, use of high efficiency motors, integration of various speed drives. If there is a process requirement नहीं तो speed drive कम कर सकते हैं, on off control change कर सकते हैं, use of energy efficient transmission change कर सकते हैं, replacement of pulley, coupling system change कर सकते हैं, gear coupling, hydraulic coupling change कर सकते हैं, direct coupling कर सकते हैं. That way we can finding out the audit of the motors. So that's why auditing is very important. You can find out who is the losses, and that from the losses we can consider possibility. We'll find out on that possibility we can carry out the modification in the system. Similarly, then there is a standard format for report preparation. These are the standard givens. Morning also they may be explaining that only just audit is not a complete. Just audit completion is not a factor. After completion of audit, there is a way have to submit the action plan, short term, medium term, long term action plan, and every 3 years the audit report to be audit to be conducted and report to be submitted to the government, return file to be submitted to the government. So they will monitor. Otherwise, people will not do because everybody charges and there is because everybody auditing the charges or for improvement there is some charges up. No one will try once if there is no push, no one will do for that auditing and improvement in the system. But that's why this law pushes the people, pushes all the systems, and it is really useful. It saves the energy, proper auditing and implementation of small energy constant load motors, under load spin that one. Here they are form Energy Efficiency Service Limited company, regulatory thing, and these power finance, four parties are there, and there is a process. Okay, you can change your motors. How there is a process. Ask the data for the motor data. That is, what are the motors available with you? What are the ratings of motors available, and what are the loading of motors available, what are the life of motor, when they are installed, what are the efficiency of motor they are collecting from the industries, and then this ESL they give the manufacturer taking the motors from efficient motor from manufacturer and giving your industries. They are purchasing the motor from high efficiency energy motors from the manufacturers and giving to the consumers, or you can consumer industries, and through for that purpose they are taking the loan from the power finance or banks institutions. They are taking the loan and doing the repayment through them only, and that repayment they are collecting from the industrial units. This is a very good initiative taken by the government. So there is a many industries, there is no worry about that. Only you give the data, they will study and they will show you that which motor we want to replace and what is the cost of that motor and what is the repayment, what is the EMI for that. So nothing to do, only you can give your data in this organization, and they will process all this data and find out how much their motor can be changed. So this is also very good initiative taken, and that way it is. There are so many industries are changing for the old motors, standard motors with the energy efficiency motors. Next, energy saving through VFD. That is also that is a once process requirement less है और हमारा मोटर ज्यादा चल रहा है, तो requirement flow ज्यादा है और process requirement कम है, और तो उसके लिए then we are putting the wall. So definitely now That is, the power is proportional to pressure into flow, and flow is proportional to speed, and pressure proportional to speed square. Thus, simply power is directly proportional to speed cube of speed. That means 10% reduction in speed, power single saving by 27%. So energy saving is proportional to the cubic of the case. That's why this is a VFD application. If there is a loss is identified, so you can easily find out easily you are getting the saving into the VFD in that. I am audible, na? Sir?
Yes, sir.
Hello?
Yes, sir. You are audible, sir.
Yes, sir. Yes, sir.
No, I am worried about it. Okay. Then this simple block diagram for VFD, the other person will also simple AC to DC, DC to AC, and by changing the frequency, we can increase the decrease the speed of the motor, very power in the system. Here you can say this I am just one phenomena, or you can say just psychologically what is the exact VFD doing. VFD is not doing anything in the motor. You can say they are decreasing the only speed of the motor. You can say this is a simple pump or the motor is there, and this is your process flow diagram. You can say there is a wall is there. If I some place there is a flow, 350 ton flow चल रहा है. Environment is 250. So what we are doing? We are throttling this wall. We are throttling this wall. That means you are losing the energy. You are losing the energy. So that here we are throttling loss. So that throttling loss can be removed by putting the VFD for this motor. So that is a simple scheme. You can say once you VFD put, you can open the valve 100%, and this flow is controlled by this VFD by changing the speed of motor. Then you can say there is a saving of the energy in the system, because through VFD, once you identify the loss in the system, you can easily save, and there is too much saving or maximum saving is possible through VFD in that process. You can simple one example, that is one CP VFD, which maybe someone person explained to you. That is a 600 kilowatt motor. Now, normal consumption 660 energy consumption 450 kilowatt. Or say this is a 150 kilowatt saving. Is the first CEP VFD installed in the India. In Dhanu, we have applied CFD for the condensation extraction pump in any power plant. After our success story, there is all power plant normally they are putting this VFD for their say condensation extraction pumps. You can think one unit, one CP can save this unit per month. Can save thousands of plants, and or similarly, you can say how much unit can save. How much unit can save, that is how much capital cost save. There is no generating. We can say 2 or 3 500 megawatt plants is not required for that. That is that we are generating. That's the only thing. Only one saving. If we implement it to all over the industry, it will save the more or more, you can say, or contribute the many things in multiple system. So one first time we do energy consumption with VFD 450 kilowatt आ गया और net saving 150 kilowatt हुआ. This is a 150 kilowatt saving is the first CEP in Dhanu. We are the first in the we have applied the VFD for the condensation extraction pump in any power plant. After that, normally they are putting this VFD for their say condensation extraction pumps. You can think one unit, one CP can. There are now thousands plants, and 1,000 plants they are applying this CP for similarly, you can say how much unit can save. How much unit can save, that is how much capital cost save. There is a no generation generating, we can say 2 or 3 500 megawatt plants is not required for that. That is that we are generating. That's why only one thing, only one saving is more, save the more or more, you can say, or system. So that's why it is only one first time we do, and after that. So that's why you can, everyone should try to identify the laws and try. First in the world, we took the ISO 50000 at the same day when it launched in the 2016. And this is our first in the world, not in the India only, in the world. In Dhanu, we are implementing ISO 50000 works. This because we have the system, so we are trying to implement the system. We are putting the standardization for the system. So here you can see that the ISO 50001 standards we took for that, and in these standards there is a all systems are defined. They continuously defined, you can say, standardized specific requirement of establishing and given the targets, make a prepare the policy for that, conduct energy review, identify the equipments with the significant energy use in our plant. We identify the many equipments, establish the baseline. सब इसके लिए baseline बनाना पड़ेगा. Individual equipment का कितना baseline है, benchmark करना पड़ेगा. Then identify energy performance indicators and set objective targets for the each section and implement the energy management action plan, monitor the measure process and report the results. That way, these systems are also useful for the sustainable of the system. Because only one, it is not one, it is a continual improvement process. Only 1 year it is not possible. Continually we can improve, slowly we can improve the system. So that's why we took this energy management system, that is the ISO. Now this in ISO 50001, then that is the energy management system we put here. That is because you are auditing, you are measuring at individual data, you are measuring, and then you analysis. But now the technology is available. Now technology is available. We are not required to measure. Online data measuring is possible. Online data recording is possible. So for that purpose, we implement that is a energy management system. One system is we install ELAN system, and in the ELAN system, all energy meters, all motors, all 90 kilowatt above motors, we put all energy meters, around 350 energy meters we put, and that 350 energy meter data is collected in ELAN systems, and we can monitor instantly. We can monitor which motor taking the higher current, which pump is having the efficiency, low efficiency, or you can which area is there is an improvement. Online data is collected. So it is not only on the audit basis. Every day we can monitor, every hour we can monitor. And on that basis also you can do the improvement, you can change the process parameter, or you can change the control systems immediately, or you can take the corrective action so that you can save the energy in the system. So this is the main advantage of the online data. So here is the one just management system. Here you can see data is available for the system. Here there is a for KVA, average current, power factor, one motor equipment. Next you can see this is a group area kitna hai, building ka kitna hai, actually consumption instantly or group T is the complete. That is a data is available continuously online in your screen, and you can find out where is the consumption, what is the consumption of that equipment. Then here we will get the trend also, because from trend also we come to know that there is where somewhere is that you can analyze, and we can immediately analyze. So you can do the find out there is a loss of energy, so you can improve on that. Next you can say there is a reports also, daily report. You will get daily report, monthly report, day wise report, shift wise report you can find out, and from that shift wise report we can analyze and you can find out where in each shift, which shift there is a loss more, which shift there is the current power consumption is high. So you can take the corrective action for that, and immediately you can save the energy by online monitoring also. That's why the online monitoring of the equipment is energy monitoring is very important for that. Then you can say even complete matrix is available, or at a glance it is available for that. Trend is also available. Then not only this, here you can see the BAP example, feed water system, electricity kitna ho gaya, rating kitna hai, legal requirement is a significance of the energy consume equipment. These are the identification of significant energy consume equipment. That is a BFP, which rating is 9 megawatt, 9 megawatt rating. So it is a higher consumption in our plant. That is a motor is higher capacity motor. That is 9 megawatt motor, highest in our plant. So we can monitor that consumption of that motor, so that it will be small changes in the system only. We can save the more than 100 or 200 kilowatt in that motor system. Similarly, boiler, steam generation, coal is also important for that. Then locomotives, HHD diesel, then HVAC system, AC system is also very important. See, now the not only industry but AC is also taking the very big load in the any buildings also, or you can say in malls or in commercial buildings. Now it is compulsory to carry out audit for that also. Next, here we can see morning maybe seen, I don't know, but it is suppose one example here you can see. We are seeing the one is a green color and another is the brown color. You can see the BFP. Hello.
Sorry to interrupt you, but your slide is not visible. Means it is not changing, sir. I can see energy audit of motors 650 kilowatt only. It is not changing.
Not changing. Okay. Again, once again, I am sharing them. You can. Sharing work. Slide change. Now is okay?
Yes, sir. Now it's visible, sir.
Okay. What is the last slide you seen? This one?
No, sir.
This one?
No, before that. Yes. Energy audit of motors 650 kilowatt. This was the projected slide. After that, we have not seen anything.
Now it is visible?
Yes, sir. Perfectly.
Okay. This is again I am repeating for that. It is a VFD advantage, that is stop starting, elimination of model flashover, economic power system. This is a these are visible now. These are the variable speed drives at DTPS, 650 kilowatt, 120 kilowatt, 90 kilowatt, 15 kilowatt, 1.1 kilowatt, and 45 kilowatt. Okay, sir?
Yes, sir. It's visible.
Okay. Then you can see there is the energy management system ISO 50001. Is it visible? ISO 50001. This is a standard job we already explained, that is this standard is required basically for continuous monitoring, or you can say continuous sustainable basis performance improvement in the system. For that purpose, we took this ISO 50001. Okay, visible?
Yes, sir. Visible, sir. Continue, sir.
Okay. Then this is a Iran system, that is a Iran energy management system, which already I explained, but still I am repeating. This is in this Iran system. Is a ID fan one. You can see here. Here you can average data, phase voltage, phase current, KVA, also monitor. You can monitor online and instant basis. Similarly, here there is a group wise matrix can be formed, or you can area wise you can make a group. Okay, next slide. Group wise matrix, menu all feeder, and group wise. Is it visible, sir?
Yes, sir, it is
Hello.
visible.
Okay. Then next, here you can see here all the HT switchgear data, one HT switchgear data. We are compressors and ID fan, PA fan, everything is, we can instantly we are getting the readings of this. From that basis, we can analyze immediately and we can do the corrective action on the sheet basis or daily basis, or you can say monthly basis also. But one day basis, it is possible to save the energy on the basis of online data. Because for that we install all the 350 meters in the systems, and that data is collected at the one place only. Then trend is available. Each equipment trend is available. So that way we can find out the way which equipment is taking the less power or which equipment taking the higher power. Okay. Then next is a report. We will get the report, daily report, monthly report, or you can say shift-wise report can be possible in this system. Then next is again it is a format for that. This is a energy identification of the high energy consumption equipment. That is the one we identify the BFP, which we have in the 9 megawatt capacity BFP. So we are identified as a more you can say more power consumption equipment, or which are the called the in ISO 50001 you can call, you can say the energy consumption or energy review equipment. Boiler, coal consumption is there, locomotives, oil consumption, and HVAC system also is very important for this issue. Significant equipment, that means significant power consumption for the particular equipment. So by changing small thing in a significant equipment, you can save the more power, because there is already more consumption in that equipment. Then this is it visible now? Daily energy deviation report. Yes, sir. Hello.
Yes, sir, visible.
You can see here, because this very important slide. You can see here the BFP1, because all data collection, data analysis we are doing daily basis and instantly daily basis, sheet basis. But on that basis, we are preparing the daily energy deviation report. You can see this is also one of our patented system. This system is already patent. We got patent on that, because energy deviation monitoring is we got patented for that year. So here we can see here BFP1 as example. We can say average as on date. You can say here 8 megawatt. You can say, or 8.063 megawatt, and base value is 7.8 megawatt. You can say, and operating value is 7.809 and 7.892. Operational control is a 7.8 to 8.8, and maintenance control greater than 8.8, and running hours 24. So, but here you can see there is a color. That means what? This color is, you can say there is a operation control. This shows that these equipments running in the operation control. Operational control means there is some process modification, process changes is required, some correction is required. We can control by operation, by changing the operation system, we can reduce the power consumption of that equipment, that motor. That's why it's called operation control. By studying or by taking the readings, by analysis, we find out we prepare the range for the operation control, maintenance control, and operating value. The in between the operating value, that is okay. There is no issue about that. It is a normal operation control means there is a chance of improvement. So once it is going this range, the color will change. Immediately inform to the particular person, or you can say particular operation department. So he will take corrective action and reduce the power. Similarly, if it is a maintenance control, then it is maintenance control. Just here you can see one is a 0.867. That is a red color. This is audible, no, sir? Red color. That is shows these equipment. CP2B is a maintenance control. So maintenance control, the maintenance people should do the preventive maintenance, or what are the corrections required, they carry out and they reduce the power consumption of that equipment. That way we can monitor our motor consumptions, because anything in the system, it directly affects your motor consumption basically. Next is it audible, sir? Hello.
Yes, sir. Yes, sir.
Okay. Next slide is we can till that we see that is how the energy system, why it is required, why motor is auditing is required, what are the motor losses, what are the probability of the potential in the motors, then what are the system modifications, your system supply affecting the motor, then how the power do in this area, that is what you are taking the ISO 50001, then how we can prepare the report, then for correction the data, we install the all energy meters, they monitor daily. On that basis, then you can see the we prepare the review report. That review also is very important because हमने data collect किया लेकिन review नहीं किया तो फायदा नहीं उसको. So for that purpose, 1 minute. Sorry. So on that basis, we energy deviation monitor करके we can save the energy. That's why we are in the Dahano. We can proudly say that our power consumption is in the India, at least we are the lowest power consumption power plant we are doing here. So this is because it is not a one-day job. It is a continual improvement. By doing all these things, every day we are improving the system of. Next point is that after that you can say is what is the forward path.
Hello, sir. Nerkar,
Hello.
sir.
Sir, your screen is not visible, sir. Nerkar, sir. Nerkar, sir, your screen is not visible. Nerkar, sir, you are not audible to us. मी पण इकडे बोल नेरकर सर your voice is not audible and screen also not visible, sir. Kindly yes, dear participants, again because of network issue, sir has left the meeting. Sir will join soon.
Now I'm joining.
Sir has joined.
Last point is already seen the last slide. Is what is the potential for that, or it is
Sir,
screen?
yeah, please share your screen, sir. That is better.
This slide is visible to you. This one. Last it is about what is the potential for that, or it is
Sir, you are not audible, sir.
Yes, sir. Hello.
Yes, sir, you are
Is it
audible, sir.
visible, sir? Okay. Yeah,
Screen is,
path already explained, but maybe
the screen is not shared yet, sir.
हाँ sir. I am audible, sir.
Yes, sir.
Yes, sir, you are audible, sir.
Last slide.
Yes, dear participants, there is some network issue due to which sir has left the meeting, and some disturbance is there because of network issue. So we'll start our session soon.
I am audible, sir. Hello. Hello.
Yes, sir.
Hello, sir.
Yes,
You are
sir.
audible, sir.
अपना भी चैलेंज होने से बोलूं
Sir, now you are audible, sir. Hello, sir. Hello, Nerkar, sir. Am I audible? Hello, Nerkar, sir. Am I audible?
हाँ, I am audible.
Yeah, yes.
नेटवर्क का थोड़ा इशू है, बोलिए आप कुछ क्वेश्चंस.
Oh.
First of all, sorry for there is a network problem from our side. There is a, I think, sorry for the interruptions, but there is no issue now. What to do now? So anything questions you require, you can ask or any.
Yes, sir. Thank you, sir, for the excellent session, which gave us good insights on motor efficiency, then the energy audit and energy management
Yeah.
of motors. I would like to ask a few questions on behalf of the audience. May I proceed, sir?
How?
Hello. Sir, there is one question. Like, what is the approximate energy savings in the motor if we club it with the inverter technology? And is it feasible in the industries?
Inverter technology, na?
Yes, sir.
Inverter, that means we can say VFD.
Yes,
right?
sir. Yes, sir.
VFD. Through VFD, there is a possibility, there is a basic, not only for motor. VFD is applicable for the process requirement. Suppose the process, there is a loss. Suppose we require we have the one pump, 300 kilowatt pump we have, suppose. Uska flow hai, suppose 250 ton flow hai. और सिस्टम की रिक्वायरमेंट सपोज 150 टन है, तो उस केस में by using the VFD we can save the energy, because by applying the VFD for the motor it will not save the energy. So it is basically process modification, process requirement के हिसाब से you can save the energy. That's why VFD is applicable for the process requirement.
Okay, thank you, sir. Yes, any other questions from the audience? Okay, I would hand over to Professor Poddar sir now for the vote of thanks.
Okay.
Thank you, Panaskar, sir. It is my privilege to propose vote of thanks on this occasion. I, Professor Prathamesh Poddar,
Okay, sir.
on behalf of MTC's RGIT, Department of Mechanical Engineering, and on behalf of organizing committee of AICT AQIS sponsored online 1 week short-term training program on recent trends in energy management and audit, and my own behalf extend a very heartily vote of thanks to Mr. K.R. Nerkar sir for accepting our invitation and as a resource person and sparing his valuable time with us. He has given good insights on the topic of losses and efficiency of induction motor, motor efficiency, factor affecting motor performance, and many more. Thank you, sir, for your valuable time and for your informative session. Thank you once again, sir. So by this vote of thanks, I'll conclude for this session and I'll close the meeting.
Okay. Thank you, sir.
So thank you. Have a